Hey y'all, this is Dr. B. This is an introduction to basically assembly, computational assembly and pattern matching. And we're going to be talking about something called suffix tree. Um, so let's get fundamental here. This is Microsoft Word, and I'm a huge Deadhead, so I listen to the Grateful Dead, and if you don't, you should. These are just some lyrics from a song. And let's kind of relate this to how computational assemblies might be done in genetics, or how when you are inputting a small sequence, how do these computer systems analyze the matching of the sequences? And there's a lot of different ways they do it. So fundamentally, you can just think about something like, well, what if I do right now like a control F? Let's just do a control F. And that is going to allow me to look for certain words in line. So now you see on the left I have the navigation, and one way that we could search for things would be, what if I wanted to find if the word pale was there, P-A-I-L. And you'll see that it is. There's the word pale. And so that's great. And of course, you'll see that's only there one time. What about the word fire? And if I do fire, I see that it's there 9 times, once in the top and then it's there. But where this gets tricky is, what if I want to look for all the indications of, for example, like just an F? Okay, there's 14. And then an F and an I. Well, then there's 9. F and I and an R. And then an F and I and R and an E. And then F and I and R and an E and an exclamation point. And then F-I-R-E and then a T right after it. And you'll notice there's none. So the analogy here is that these particular algorithms to try to identify and compare sequences, and again, a lot of this is just for like comparing and matching patterns, it would be really difficult to do this if I wanted to know all the combinations of the ways that just an F and an F and an I and an F and I R and F and I R E, F I R E and an exclamation point. How's that decided? Because there's so many possibilities, and that's where we can kind of use a particular tool, because we are not limiting ourselves to a fixed length of searches. And so how can we process the idea of the nature of these things to be searched? So we could use the fundamental word fire. So let's just say we do that. Let's just take fire, for example. If we look at this, we have a particular way that we do this. And one of the ways that we do this is just take all the particular strings, and basically for the string, there's a particular tool we're going to use called a suffix tree. And so let's look at all the strings in something called fire, and then I will define what that is. So here we go, F-I-R-E. And then what I can do is I can break that word down further to I-R-E, and then break that word down again further to R-E, and then break it down one more time to E. So now this might seem a little confusing, but basically think about it this way, that for each position in a character string, its suffix is the substring that starts at that position and continues to the end of the string. So for example, for the word fire, we can see that the suffixes are F-I-R-E, I-R-E, R-E, and E. So I know that sounds a little confusing, but now I'm going to take that idea and just kind of show you how some bioinformatics searches work using that idea. So let's just take something like this. C-A-G-T-C-A-G-G $. Now you may be wondering, like, what is up with the $? So the $sign is just basically like the end of a string. And so if you think about all the possible strings there are, there's going to be G with the $, GG $, AGG, you get the idea all the way down. And so that's kind of what we're going to build. And so I can tell you right now we're going to have 4 branches at most. And the reason why we have 4 branches is because we only have 4 characters. We have A's and T's and C's and G's. And so let's start the way that they would start, which is basically the end over here. So the first thing is G. Do we see a G anywhere? Of course we don't. We don't see anything. And so basically what we're going to do is create our first branch, and we're going to say G $. Now there's something else we can do that can kind of help us keep things organized. And the first thing is to label all of our indexes. So I'm going to go 1, 2, 3, 5, 6, 7, 8. So those are called indexes. Let me move this down a little bit so you can kind of see that. There you go. So those are indexes, and basically that's all of the different characters we have. So these things are the number of indexes, in other words, which ones are in order, but the individual letters are called suffixes. So, and the string is the root of all the suffixes for every single root string. So let's just start here. So first thing is, do we have a G? We don't. So we drew one, and we could kind of, if we want to, just kind of do like an unofficial, like that's number 8, right? So now let's go to the, so we just did that one. So now let's do the next one, which is GG. So first of all, do we have a G? Oh, look, we do have a G. So we don't need to make another branch because we have one. So at this point, what are we going to do? Well, at this point, we have to kind of branch this off. And the 2 ways that we're going to branch it off are going to be kind of like this. So like, to look at it another way, we have the G here, right? So we have now yet another G. So if we go down the first G here, well, what are we going to do? We're going to have to split them. And so we're going to split this one now into $8, and we're going to get rid of this. And then another thing we can do from here is now branch off to another one, which is going to be the second G, and that's from the 7th index. So it could end a G where there's just the $, or it can be GG. So now and it'll make a little more sense when I keep continuing on. So let's just add like yet another one. Let's go to the A. So the first thing is do we have an A branch here? And we don't have an A branch. So we're just going to add an A branch. I'm just going to kind of go out here like this. And so we start and we say, all right, well, we have an A. All right, well, A and G and G and $. And then that was from the 6th index. And that's a new branch because it started with an A, and so we don't have anything. So as soon as we start a new branch, we have to do the entire rest of the suffix from that new branch. So that's why it's AGG. And now we move to another one. And the first thing is, do we have a C? And the answer is we don't. We only have a branch for an A and a G. And so let's now add over here just a C, and of course we have to write the rest of the string because it's a brand new branch. This is going to be C, A, G, G, $, and that was from 5. I just do the 5 right there to just kind of keep myself in order. And then we go to the next one. Do we have a T branch? And the answer is no. We have an A and a G and a C, but we don't have a T branch. So let's just kind of put that one out here. And that's going to be T, C, A, G, G, $, and that's going to be our 4th index. And so far we're kind of rolling. So now what happens, let's go to the next one. I'll just put these on top because now we're running out of space in the bottom. So the next string is going to be the one for the 3rd index. So do we have a G? We do. All right, we have a G. Do we have a GT? No, we don't have a GT. So we now need to create another branch from this spot because all we have is a G ending, which was this one, or we have a GG, which is this one. So we need to create another offshoot of that, right? Another leaf. And that one's going to be our T, C, A, G, G, $, and which index is that? That's the 3rd. So it's read as G. So what do these things mean right here? This is the tricky part. Well, basically we can see here that which search set of strings do we see that starts with a G? Well, we have just the G and then there's the end. This one is a G and then a G because we can go to the end or we can go to the second G, and then the next one over there is a G, which we have that, and then is that the end? No. Is it GG? No, it's GTCA. So that's our next leaf from that point. So we did those. So now let's go and do the A, and let's just say ourselves, okay, so do we have an A? And we do have an A. Actually, we have a, so okay, that's good. So we have an A. Do we have an A and a G? Yes, we do. We do have an A and a G. Do we have an AGG? We don't. We have an AGT. So what we have to do is cross this off right here, get rid of that stuff. And that's basically now got to be its own leaf right there, G $6. All I did was cross it off and move it to its own, because now there's another way we can go, which is we can go AG, and now we can go the rest of it. TCAGG, and that's the second index. And then we get to the last one. Do we have a C branch? We do. Do we have a CA? We do. Do we have a C? Ooh, we're doing good. Do we have a CAG? Yes, we do. Now what? Do we have a CAGG? No, we can see here we have a different letter here. So what are we going to have to do? We're obviously going to have to, the CAG is going to stay, but then we're going to have to take all this stuff right here, right? And we're going to have to branch them off. So that's going to be, right? That's going to be a G $, G $. I should make that like a G. And then that's, I think, the sixth, or what is that? Fifth one. All right. And then also the, oh, I just lost the video for a second. Okay, we're back. I guess because I hadn't touched the mouse in a while. Yeah, so basically now we see again our last one, we're going to get rid of the G in the end. We put it over there. So now we have our C, A, G, and then of course we're going to have a new branch, right, which is going to be the rest of it. T, C, A, G, G, $, and then that was first, so we have our G5, right? And of course we have, don't forget about the index move. We're going to kind of move these to the end, you're going to see here in a second. So in terms of moving those, you can do it, there's a whole bunch of different ways to kind of label them. You notice how I labeled them here, but what I typically like to do is just kind of put them on the ends, and some people do that as well. So obviously this one is a 4, this one is the 5, this one is the 1, this one is the 8, this one is the 7, this one is the 3, this one is the, I'll just kind of make it a little ball, 2, and you'll see that this one is the 6. So I'm going to now just redraw it real nice and kind of explain it again from that point, so you can just kind of see how this actual, what it looks like for real when it's done, you know, cleanly. So here it is redrawn much neater. Apologize for this little 6 right here. So now that you kind of see it, again, let me just kind of go over how I did it. So the first thing was I started with a G branch, and there it is. And then there was a GG. Well, I already had a 1G, and so then there is the second G. So this branch is the G ending, which is why it's the 8. This branch is GG, and then it ends, so that's 7. And the next one is an A, and I didn't have an A. So basically I started an A. G, and of course it was originally AGG, so there's my AGG, but later on we'll talk about how this branch that I'm going to hide here, right, this one wasn't here yet. So you can kind of see that that 6th one was just AGG, and there it is. So now let's do 5. The 5 one, did we have a C branch? No, we didn't. So we created it. So we started a C, A, G, and then we had, again, this branch wasn't here. Right here, I'm going to cover this up. So all we had was the rest of it was CAGG, which was in a straight line. So then we have enough. Do we have a T? No, we don't. So now we move over to the T, and we have TCAGG $, and of course that's the 4th one. So that why the index is on the 4. Then we move to the 3rd. Do we have a G branch? We do. Do we have a GT? And at the time, the one I'm hiding didn't exist. We just had that. No, we didn't have a GT, so we had to create the G, and then there's the rest of it. TCA GG $, and that was the third one. Then we go back to the A again. And if you remember, we only had what you see here before. Do we have the A? Yes. Do we have the G? Yes. Do we have the T? No, because we only had A, G, and G. So we had to create a rest of the stem for TCA GG, which was the second index. And then last one, we go back down to we have a C. Of course, we had only had, I'm going to cover, we'd only had this before, which is CAGG. So here's the C and the A and the G. But the fourth letter is a T. It's not a G. So we had to create a new leaf or branch off of that. And that's going to be TCAGG $. And that was from the first index. So that would be the suffix tree for that particular series of search. So I'm gonna my second video is going to be one that is I found on the internet that's using a word as another way to do it that might be a little easier. So hopefully that helped.